Hi, I'm Anthony Wessel, and I recently decided that I'm gonna make a YouTube channel to try and explain some topics in math and science, because like maybe you didn't get it, your teacher didn't explain it very well in class and you're still kind of confused on it, or maybe since schools are closed during the time I'm recording this and teachers are generally having a tough time conveying information to students, maybe I could act as a second resource for that. So yeah, I'm gonna try and help people with math and science questions that they have. So I hope you enjoy the video. If you're in Algebra 1, you've probably seen a quadratic equation before, and you've probably been taught several ways how to solve it. One of the ways your teacher probably taught you is with the quadratic formula. And your teacher, if they're like my teacher, probably just showed you the quadratic formula and was like, yep, that's how you solve it. Put the numbers in and you get the right answer. But that didn't sit well with a lot of people because like you can tell that they're related inherently because the x's, all of the variables are still there. So there has to be some way to get from the quadratic equation to the quadratic formula. And that's what I'm going to show you today. So the first step is to really know what you mean by solving the quadratic equation. When your teacher says to solve the quadratic equation or find the zeros of an equation, what they mean is to figure out what values of x will make y equal 0. So like the equation would be set to y equals the equation, and you want to know what values of x make y equal 0. So, and that's that's the same as an x-intercept. So with a linear equation, y equals mx plus b, it's pretty easy. All you do is a little bit of algebra, set y equals 0, subtract b, divide by m, and you have x, wherein y equals 0. The problem with trying that with the quadratic equation is it's really hard to isolate the x. If you don't know exactly what you're doing, you'll probably just mess around for a little bit, go in circles, and you won't be able to isolate it because there's one specific way to do it. And I'm going to show you that specific way to do it. So the first step is, since we want y to equal 0, and we know that this is going to be equal to y if we graph it, and we're going to set this equal to 0. That way, when we isolate the x's, we know that whenever we plug in that number for x, it's going to come out as 0. So the next step involves something called completing the square. You might have been taught how to do this in order to solve a quadratic as well, but I'm going to reteach how to do it for those who don't know how to do it. So what does completing the square even mean? So completing the square has to do with perfect square trinomials. Now, a trinomial is just an equation with 3 terms in it. Like here, we have the a squared, 2ab, and the b squared. 3 different terms. That's a trinomial. And here we can see that I've written that it's equal to this a plus b binomial, a binomial being an equation with 2 numbers, or 2 terms in it, and we take that whole quantity squared, and it's equal to this. Now, how do you get from this to this? Well, you might have also been taught something called the FOIL method. So FOIL stands for first, outside, inside, last. And it's how you multiply two different binomials together. Or, in our case, two of the same binomial. Because since this is squared, that's the same as multiplying it by itself. A plus b times a plus b. So we can use the FOIL method in this case. So we do the firsts, a, and we get a squared. And then we do the outsides, a and b. So we add a, b. We do the insides, b and a. That's ba, but because of the commutative property, it's the same as ab. So we add a, b. And then we do the lasts, plus b squared. So this is already looking familiar with these terms. And then, if you know how to combine like terms, you just, these ab and ab are like terms. So you add them together, there's two of them, so it's a squared plus 2ab plus b squared. So basically, this whole thing is just the short way of writing, well, this is equal to this, which is equal to this, which is equal to this. Because all of them are equal, you can just go from the first step to the last step, be a lot more concise. So, now that we know how about perfect square trinomials, what we want to do is try and make this into a perfect square trinomial, because then we can turn it into the binomial and then isolate x if we have x as one of the terms of the binomial. Specifically, where we want to make it the a term, or the first term, not to be confused with this a right here. It's different. We want x to be the first term in that binomial. So we have to turn this into a perfect square trinomial, thus completing the square. We're completing a perfect square trinomial. So, what's the first step? Well, we know that the first term of the perfect square trinomial is just the first term of the binomial squared, and we want x to be the first term of the binomial. So we have to get x squared all on its own. So to do that, we just divide by a. But we can't just divide this part by a. We have to divide the whole equation by a. So here, a cancels out, and we get x squared. With bx, we get plus b over ax. Or you could also write it bx over a, but for the future, it's easier to write it b over ax. And then we have c over a equals, well, 0 divided by a is just going to be 0. So, 0. Now, we need to make the last term of the perfect square trinomial, which is b squared, or the second term in the binomial squared. So, we want to subtract c over a so that we have a space for that third term, because c over a is not that third term. So we subtract it, x squared plus b over ax equals negative c over a. Now we want to get that third term. How do we find it? Well, we know that x, well, first, we know that the middle term is going to be 2ab, or 2 times the first term in the binomial and times the second term in the binomial. And we know we want our first term in the binomial to be x. So we can disregard that as being a. So this is 2b. So to get b, we get, and we want b so that we can get b squared. So to get b, we divide this by 2. So divided by 2 is the same as multiplying by 1/2, which is good for this fraction. So it just becomes b over 2a. And then we want b squared, so we square it. Sorry for the parentheses. And squaring a fraction is just you square the numerator and square the denominator separately. So we get x squared plus b over ax plus b squared over 2 squared is 4, a squared is a squared, so it's 4a squared equals, and since we're adding this to this side, we want to add it to the other side too, so that it's balanced, the equation still equals itself. So we have b squared over 4a squared minus c over a. Now what do we do? Because there's a lot of squares and b's and a's and variables everywhere, so we gotta make it more concise. So on the left side here, well, we just made a perfect square trinomial, so we can turn it into the binomial that it's equal to, which is going to be x plus. So where was I? Right, so we just made perfect square trinomial that we can change back into the binomial form. So we have our first term, which is x, plus our b term, which is b over 2a, b over 2a, and then all that squared. And then we have the other side. So we've got subtraction of fractions, and to do addition or subtraction of fractions, you need like denominators. So we have to make c over a have a denominator of 4a squared. And to do that, we just multiply the fraction by 4a squared over 4a over 4a, which gives us 4ac over 4a squared. We have like denominators now, so we can subtract, which gives us b squared minus 4ac over 4a squared. And if you know the quadratic formula, that numerator will look really familiar. It's the term underneath the square root in the quadratic formula, which is also called the discriminant, because it determines whether or not you'll have a real or imaginary solution, which is a whole different thing. Yeah, imaginary numbers would be a whole video, if not a video series of its own. But anyways, so now we have to get rid of that square. So we square root both sides, which cancels out with the square on this side, and square rooting a fraction is similar to taking it to an exponent. You do both of them individually. So that leaves us with x plus b over 2a equals. So this, we can't like take anything out of that with the square root. It's all one term that you can't separate. So it's gotta be b square root of b squared minus 4ac over, but this can take the square root of, because it's just this squared. So we have 2a. Now we just need to isolate the x, and to do that we subtract b over 2a from both sides. And oh look, we have like denominators. So it's as simple as x equals negative b. Oh, one other thing actually before we do that. The square root, it can have two solutions. It can be positive or negative. Think about the square root of 4. That's 2, because 2 times 2 equals 4. But it's also negative 2, because negative 2 times negative 2 equals 4. So square roots have both positive and negative solutions. So now we can continue with isolating x and subtracting b over 2a from both sides. So we have negative b plus and minus the square root of b squared minus 4ac all over 2a. There we go, our quadratic formula. Now we can see how we would isolate x from the quadratic equation. You just have to use the specific step of completing the square. And now we see the relationship between the two. Thanks for watching the video. I hope that you enjoyed it, and if you have any math or science related questions, please just leave them in the comments below.